Today we are going to talk about finding the area of composite figures. We have learned that composite figures are 2D figures made up of other 2D figures, such as squares and rectangles. However, we need to figure out how to find the area of these figures because they can be all different shapes, all different sizes. So we need to figure out how to do that. There's two options when we are finding the area of composite figures. The first is to decompose. When I think of the word decompose, I think of like worms decomposing. So what the worms are doing is they're breaking like the food and the soil down. So they break it down. So what I could do is look at this H and say, you know what? I don't know the area formula to find the area of an H, but I see that there are 3 rectangles within this H. So if I draw 2 lines, breaking this down, I've got 1 rectangle, 2 rectangle, 3 rectangle. I would find the area of each one separately, and then add them together to get a total area. So that's to decompose. I break it apart into shapes that I already know the area formula for. The other option is to compose. This is where we would build it up. Again, with compose, I think of the word composer or composing music, and I think of like building and creating music. So we would build this up. And I would see that if I have this H, I can connect those pieces there, getting me a full rectangle. So what I would do is find the area of the whole, and then I would subtract these added on parts, the areas of those added on parts, subtract added parts. Okay, so to compose means we're going to build it to a shape that we already know the area formula for, and then take away parts. This year, we are going to focus on the decompose. So if you would like to give compose a try for a couple, you are welcome to do so, but we will focus on the decomposing, breaking it down. All right. When we are doing this, you're going to ask yourself a couple of questions. The first is, what shapes do I see within the composite figure? So here we saw rectangles. Maybe you see triangles. Eventually, maybe you'll see circles. What shapes do you see within? The next question is, do I know the area formula for the shapes I see? So if I see a trapezoid somewhere, that's great and all, but I don't have the area formula for a trapezoid, so it's not going to be incredibly useful to me. Triangles, rectangles, I have those formulas, so those are helpful. And then how can I find the area of the full figure using the shapes that I see? So you can break it down. So here we broke our figure down into 3 parts. You can do more than 3 parts if needed, sometimes maybe only 2. I've got a couple of examples here. We're going to draw 1 line to decompose the shape below in a way that would allow you to find the area of the composite figure. At least 1 line. So for here, I can find the area. I could draw a line right here. That would break it down into 2 triangles. If I chose, I could actually instead, so this is not in addition to, but instead, I could have done this and done these 2 triangles. So either option works. Here we have a trapezoid, and yes, there is an area formula for a trapezoid, but what I could do instead is if I just draw this line, I have 1 triangle, 1 rectangle, and another triangle, so I could find the area of each of these and the rectangle and find the area that way. When we do this, we want to make sure there's like a natural line. So it wouldn't make sense for me to draw a line here because that would mean it'd be the middle of this triangular shape and I'd be left with a funky shape that I don't know the area formula for. So we want to make sure it's natural. So for example, right here, And we want to do as few lines as possible. Sometimes you have to do more, but we wouldn't want to also like put a line here and find the area of this rectangle and this rectangle. That's just not necessary. One line is enough. All right, let's go ahead and try a couple here. So it says, find the area of the composite figures below. So again, we do want to go ahead and make sure that we are only putting as few lines as possible to make our lives a little bit easier. However, for this figure, I could either draw a line here or I could break it down here. And the choice is yours. So both, if you break it here or you break it here, you should get the same area if you do it correctly. I am going to break it down right here. Okay. I am going to then label my two shapes. I have one rectangle, looks like a square, and another rectangle. So step one was to decompose and then go ahead and label. From there, I'm going to look at this shape. I go back to what my area procedures are. So area, and then I put a little 1 here. Area of figure 1, in case I need to go back and check my work. I know which area I was finding. What figure is this? Well, it's a rectangle, so I'm going to use my rectangle formula. And then I'm going to go ahead actually and do it for my second shape right away as well, which is base times height. Then I go label. Okay, what's the base of this one? Well, it's 3, and the height is 3. So I could go ahead and finish this one up if I wanted, or I can go back and forth, kind of work whatever works best for you. 3 times 3 is 9 centimeters squared. So this figure 1 is 9 centimeters squared. Now I'm going to go to this one. I see that this is the base, which is 10, and the height, I don't have a height, but I have, this is 5, and this is 3. 5 minus 3 gets me 2. 2 right here. 2 is my height. So I go ahead and substitute in 10 times 2. Multiply those, getting me 20 centimeters squared. So now I know that this is 9 centimeters squared and this is 20 centimeters squared. So my next step is to put them back together. 20 plus 9, 29. My answer is 29 centimeters squared for the area of this entire composite figure. Now, on the answer keys, I'm simply going to write the final area. And the reason for that is sometimes you might have chosen to draw your line here, meaning that our areas here will be different. And that's okay. As long as our final outcome is the same, you're good to go. So I didn't want to confuse anybody. If you would like me to look at problems, I am happy to do that. If you would like to compare with somebody else, that's all right as well. All right, we've got one more example together here. We've got number 2. And if we take a look, we ask ourselves, we look at our questions from before, what shapes do I see? What shapes do you see in this figure? Yes, I see a rectangle and a triangle. So I'm going to draw my decomposition line, my line to decompose, right where those meet. Now I'm going to label 1 and 2. I'm next going to write my area formula for each. Area of figure 1. Well, figure 1 is a triangle. So I'm going to use my triangle formula. Figure 2, area of figure 2, is a rectangle, so I'll write base times height. Now, I go ahead and label my figure. For my triangle, what is the base of this triangle? Yep, 11. So this 11, since this is a rectangle, this is 11, and that is my base. And I already have my height of 7. So I continue. Base is 11 times 7 divided by 2. Over here, my base is 11, while my height is 8. Oops, I did not mean to write 7, excuse me. 11 times 8. And now I've substituted. I can just simply evaluate. 11 times 7 is 77 divided by 2. 77 divided by 2 is 38 and a half centimeters squared. 11 times 8 is 88 centimeters squared. What is my next step? Add them together. So 88 plus 38.5. What is the area of this entire figure? 126.5 centimeters squared. And there you have it. You go ahead and you take a look at your figures. Either one, you decompose, you break them down into their shapes, shapes that we know the formulas for. You label those, write the area formulas for each. Having that little 1 and that little 2 allows me to more easily, if I need to go check my work, I am like, okay, this is the 1. Let me make sure my numbers are correct. I label my figures, my 2 separate shapes or more. I substitute in, evaluate, add them together, getting me my final area.